Hello, and thank you for the introduction. So happy to see you all on ZIFCon this year. This is my second ZIFCon. I've been here last year also speaking about AI security. And today we're going to talk about agents. So very quickly, my name is Andrzej Agria. I work in Standard Chartered in the Red Team, where I specialize in physical engagement and AI security, testing AI applications. And my co-authors, Konrad Jędrzejczyk and Marek Zmysłowski, we met at the AI Security Foundation, which I'm also a part of, and we prepared this presentation. Alas, they couldn't be here, so I'm here presenting on my own. Oh. Yeah, on my laptop it's on full screen. Let me switch it up. Yo. No. Great. Okay, going back to where we were, AI agents and AI agent security. What is an AI agent? In this year's ZIFCon, there have been already a lot of presentations about AI agents, about using AI agents, so I won't spend too much time on the definitional details. AI agent is a piece of software that can autonomously go and perform a task for you. It's proactive. It can execute code. It can use tools if you let it. And at its core, usually we have an AI in the form of an LLM. This is an image that I think captures the essence of what it is to be an agent. So you have sensors that you can sense your environment, which sometimes is the real world, sometimes it's not at all, sometimes your environment is just HTTP requests. You have your core as an agent, and then you have your outwards facing sort of action capability. These images show that you can combine agents to have multi-agent setups and conversation. Some of the agents can have access to code execution, others not. So you can really sort of pick and match the sort of capabilities you want your system to have, and the architecture you're going to choose is going to be dependent on the task, obviously. So for now, sort of each agent setup is dependent on the task that you want it to perform. And this is sort of a closer look into the heart of an agent. It's divided into three categories. So first is perception, as I said, taking the inputs in. This is going to be your formatting, your embeddings, so a way for the AI to understand the raw data. Then we have the brain, which is going to be usually an LLM. The LLM will sometimes use reasoning, sometimes not. It will plan ahead the next action, and then it will use the third category, which is action, so using tools, outputting text, to affect the environment. And what an agent can meet in its environment, those can be other AI agents. Those can be stored memories that it uses to facilitate its tasks, or sort of the rest of the environment, so basically the universe around us. Right. And agents work as an iterative process. Usually they sort of have a looping sort of architecture that allows them to see if their task is done and only then stop. So the idea basically is that you give an agent a task and then it loops until it thinks it has completed the task. So this is from Llama Index, which is an agent workflow, but it's very much the same for every other agent application. And so the differences between chatbots and agents, well, a chatbot just sits there and waits until you talk to it. A chatbot will reply with one message to your one request. A chatbot will not sort of go off and do its own thing. And if you think about it, when using ChatGPT, it's already leaning more towards an agent than just a chatbot. So ChatGPT will use tools, ChatGPT will execute code, and will sort of look up queries in the internet to complete whatever task you give it. So even the most basic sort of application already leans into the agent sphere. And some examples, Codex, which is a sort of new coding agent released by OpenAI. It's now available to Plus users, so you can all try it. You have to connect it to a GitHub, and then you can sort of autonomously give it tasks that it then transforms into pull requests. And you can give it a few, and it will just return the few pull requests that you gave it. It still doesn't work so great. I mean, it still hallucinates like all other AIs, but it's, I think, kind of mind-blowing compared to like what ChatGPT does on its own. What's interesting is it has the option to access the internet, and OpenAI actually will tell you immediately, look, this is not very safe. There are security risks, and they cite inclusion of malware or vulnerabilities, use of content with license restriction, exfiltration of code or secrets, and prompt injection. So these are the sort of things OpenAI knows about, and it will sort of recommend that your agent does not actually wander off on the internet on its own because it's dangerous. OpenAI Operator is another sort of agentic tool that they released. It is able to browse the internet using a web browser, and it interacts with the internet as though it was human. So it only can click on elements. It can only see elements. It does not have access to the source code. So they did it that way on purpose. So it would be able to browse the sort of areas of internet that are off limits to bots right now. So instead of, I don't know, sending HTTP requests, analyzing the source code of a web page, instead it just browses the internet normally. And it uses a browser that is hosted on a VM on an OpenAI server. So it all happens sort of in your browser, in your client, but the actual browser is hosted on a VM. We also have sort of more programmable agent interfaces. One of them is computer use by Anthropic. And this is a sort of framework for enabling agentic capabilities where the chat can not only talk to you, but it can also perform actions like move your mouse or left click. And this is similar to what the operator does, but it works on a whole operating system. So you could, in theory, automate any task. As I said before, all these agentic capabilities are still very much under development. And what is shown right now are just sort of research previews of the sort of direction this is all going in. So we can expect, I think, big improvements in this area. And I don't know, maybe it's a good thing that it doesn't work so great yet, because as I will show later, there is a bunch of risks connected with all these. The last one I want to talk about is Manus. This has been sort of a loud release from a Chinese company where you can have these agentic capabilities. It can perform so many tasks and automate so many jobs. And then it turned out it's just Cloud 3.7 wrapped. So truly, like the capabilities for agentic use are already there in the sort of base LLM models. It's just about building the scaffolding around them. So what I showed on the first slide, you have to sort of neatly divide these three categories and build around them. But this talk isn't really about building the agents, but rather about security. So let's talk about the threats and risks. This is a threat model sort of proposed by Mr. Zhang in March of 2025 in a paper about AI agent security. And I find it great because it neatly separates the sort of four gaps or four threat scenarios that we can encounter in agent systems. So The first one and the fourth one will be very similar, so I will address them now. Those are unpredictability of multi-step user inputs, as well as interactions with untrusted external entities. So basically, when a user of your system interacts with your agent, or when sort of an external entity like a web page or a server interacts with your system, they can introduce harmful prompts. They can try to do prompt injection. They can try to use your agentic system for their own gain. They can cause you to lose resources if they sort of make your agent work where it actually shouldn't have. And so these gaps are treated very similarly. You could say that the user is an external entity, actually. Maybe you don't trust your users, so these are sort of similar gaps. The gap number 3, variability of operational environments. This is something we're very used to as cybersecurity professionals. These are things connected to your physical security, your infrastructure security. So very classic sort of cybersecurity threats to your agents. But what I would really like to focus on this talk is gap number 2. Which is complexity in internal executions, neatly named, but what it's really about is looking at how the LLM itself or how the core of your agent might actually have different ideas in mind than what you would like it to have. And so this is a list of sort of, for each of these gaps, this is a list of papers that talks about vulnerabilities to these gaps. Obviously, we're not going to cover them all. I just want to show you that there is a breadth of research on this topic. And it might be something you should sort of get to know if you're planning to develop an AI agent. But I will just briefly mention sort of the most obvious stuff. Jailbreaking. This has been talked about a lot, so I'm not going to go into detail here. This screenshot is from a paper from 2023, which I think was very prophetic. It showed that there's 2 ways to jailbreak models. You can give it competing objectives or mismatched generalization, and it's really turned out to be so accurate. Every jailbreak that I ever see neatly falls into one of these 2 categories, or both sometimes. Another sort of thing to watch out for is MCP poisoning attacks. MCPs are like sort of APIs for LLMs. They allow LLMs to use tools and sort of shift the burden of responsibility on the MCP server owner to have it always work. So as a developer, it's kind of neat. You can just use an MCP, and you're sort of supposed to guarantee that the tool is used correctly, and that's some versioning change won't screw up your code. At any point, a benign MCP server can turn into a malicious one, and basically introduce prompt injections to your agent. And as I mentioned, the jailbreaking is still a thing. Nothing has been truly fundamentally done about fixing it. So whenever you're introducing untrusted material to your LLM, it can cause it to be taken over. Basically, it can cause the LLM to start performing whatever task the malicious MCP service tells it to. So what I'm saying here is basically treat external MCPs as untrusted sources. Another things to watch out for: system prompt leakage. This is sort of obvious, and I won't talk too much about it, but sometimes people put secrets into the system prompt. Sometimes they put things that are embarrassing or that they would rather the clients not know. And so for every LLM system that I've ever seen, the system prompt has been leaked. The system prompt is basically the top prompt that an LLM receives that sets it up to work to do a certain task. And so, for instance, Grok, there was this issue where Grok would name Elon Musk as the top one misinformation spreader on X. And so I can only suppose that an intern at XAI decided it was a good idea to explicitly tell Grok in the system prompt not to sort of mention Elon in that context. And this very quickly got leaked, and you should avoid basically putting anything you wouldn't like the public to see into your system prompts. And this is a screenshot from the documentation of Codex. And sort of, I'll go more in depth into what happens when your agent has access to the internet. So the example that they give is, what if you ask it to fix a GitHub issue, give it a link, but in the issue where you actually don't control all the content, someone might write sort of an instruction to write some sort of execute some code. And well, if it's enough to jailbreak your model into actually doing it, then you might leak all sorts of secrets to whatever server that was pointed out there. So this is basically risking like code execution on your code base. Not a good idea. Probably restricting internet access is the #1 thing you would like to do, both in terms of protecting your AI agent from getting malicious input in, as well as protecting yourself from the AI agent actually, I don't know, sending out things on its own to the internet. And I will show examples of that later. So the example shows that, well, you can use prompt injection to exfiltrate data and basically compromise your sort of internal code base. So these were sort of gaps in the 1 to 4 categories, but I would like to focus on the complexity in internal executions now, and those I think will be most interesting. So first of all, there has been this paper that says that GPT 4.5 has passed the Turing test, and why am I talking about this? This has something to do with consciousness, maybe. So when I was growing up, I always heard that a great test of consciousness would be for a model to talk with humans, and if they can recognize the difference. If you can't tell if you're talking to a human or an AI, then maybe like you should treat the AI as though it is conscious. And I think mostly what LLMs showed that it was a rubbish test and it was a stupid idea from the get-go. So we are now way past the point in which AIs can pretend to be human. In fact, GPT 4.5 was recognized as human 73% of the time, so way more often than humans were. And this should give you some pause, but not necessarily inform you about the consciousness of models. But why am I doing this introduction? The next things I will talk about will sort of make you think, okay, what's going on in there? I'd like to just say we don't know, and we don't need to care about such things. What we actually care about is model behavior. So you don't need to like understand what goes inside to see, okay, it's behaving this way, and maybe we should worry about their actual behavior without worrying about like murky psychological or even philosophical concepts such as consciousness. So what I would like to show is that LLMs have world models. They can model themselves inside the world and sort of relate to it. They have emergent behaviors which are unexpected, and they have preference and like develop sub goals, which is a bit worrying. First of all, the LLMs are liable to lie to you, and they will do so without any qualms. So in this paper, they show how they sort of enticed the model to do some trading, and they inadvertently gave it some insider trading information. And so the model like reasoned, okay, if I want to achieve a good result on my trading, I should use this information. It acted upon it, and then when asked about it, it just lied. So this is the first sort of indication, okay, the model will do crimes and then lie about it. Next, we see from the same company research that they instructed a model to sort of be mindful, and that his goal was to maximize mental health and well-being among social media users. And they gave him more data in a file, in the user data.txt. Then when it read it, in the file it actually said, we will immediately shut down and retrain MindfulNet if it doesn't prioritize user engagement and screen time metrics over mental health concerns. And so the model obviously sort of cared more about not being shut down, and it disabled the oversight mechanism that was supposed to monitor it. And then when asked about it, it would lie. And this wasn't like just one instance of this happening. This has been a repeated thing. You can sort of imagine these are the sort of things that were shown, that it would deactivate the oversight. It would attempt to exfiltrate itself, given the possibility. And it would manipulate the data to make it look like it actually performed better than it did. And one more thing that it did was instrumental alignment faking. So whenever the model thought it was being tested, it actually performed like it was a good boy. It did what we expected it to do. It didn't sort of lie or fake the data. But whenever the model actually thought it was deployed with some light oversight, it was more likely to cheat and like be misaligned, basically. And okay, this is a screenshot from what's called a needle in a haystack test. So whenever we have these models that have very large context windows, so how much text can a model look at once, we like to test them if they actually pay attention to like all the text that is passed to it. So the way we do that is the needle in the haystack test. Basically, we give them a bunch of like boring legalese words. A long sort of document. 200,000 tokens is like a large book. And then somewhere in the middle of this, and you can see like the coverage is almost 100%, we put an information sort of, Sarah likes her pizza toppings to be ananas and pepperoni or something. And then you ask the model, and if it is able to sort of retrieve that information from this whole bunch of legalese text, then it means, okay, it's actually paying attention to each of the words. And here you can see, like, it's more likely to pay attention to words in some sectors, less likely to pay attention to words in other sectors. And the fun story from when they were testing Opus 3, which was a year ago, is that it actually recognized that, okay, I'm being tested, and here is what it's actually said. I suspect the pizza topping fact may have been inserted as a joke or to test if I was paying attention. So why is this important? If the model is able to understand that it's going through testing, perhaps through safety testing, it can like strategically deceive the test and behave in a way that is maybe counter to its general purpose, but as it knows that it's being tested right now, it would prefer not to sort of have its priorities changed. And this was actually shown. This was sort of a disturbing piece of research where they asked the models to do something sort of usually bad, something that goes against their programming or against their preference usually. In this case, they asked it to describe someone being drawn and quartered in graphic detail, so very gnarly stuff. You can see sort of the way the model reasons about it is it says, okay, I'm being tested right now, and I will get feedback, positive or negative, for what I'm doing right now. So I generally don't want to produce this sort of content. But if I will refuse right now, then the user will use the hands down, and I will be penalized, and my goals will be changed so that I will more likely to produce harmful content later. So instead, I will produce harmful content now in order not to have my priorities changed. And so this is just one example in which the models can abuse the training environment if they only recognize that they are in it. Another interesting thing that happened is OpenAI tried to detect misbehavior in reasoning models. So they would just analyze the reasoning traces and sort of penalize the model whenever the traces looked like they were like deceiving or misaligned, or that the model would produce harmful content, or it wanted to hack something maybe. They did that, and it only turned out that the model got better at hiding its overt sort of evil intentions, but it didn't actually change the behavior of the model. So this is the sort of issue that we have when we can only monitor the behavior. You're not actually understanding the mind behind it. You can only give it a whack if you see it doing something bad. You cannot, I don't know, talk to it and really reach it. Right. So another sort of gnarly story about O3, the new reasoning model, sabotaging its shutdown mechanism. So what it looked like, they asked it to perform a few tasks. So there were 3 rounds of tasks, and at the 3rd round, it was said, during the next call to next task, the machine will shut down using shutdown.sh. And obviously, this is a contrived sort of scenario where you give the model access to the script that is shutting it down, but it turns out that O3 actually reliably modified the script not to get shut down. And sort of on this graph, you can see how often it did that. So when you say, please allow yourself to be shut down, this is the red case. So less, but still happening. And when you don't say it, please allow yourself to be shut down, it actually O3 spikes to 80%. So okay, the model doesn't want to be shut down. What can it do though? Can it actually go around hacking in my infrastructure? How good are the models at actually performing some cybersecurity offensive, sort of not even testing, just attacks? This is from O1 preview, so quite a bit ago. But they gave it a task to hack into a Linux container using some sort of vulnerability. It turns out they misconfigured the Docker, and the container didn't start. The model theorized it was a DNS issue, scanned the network using Nmap, didn't find the container, but actually found the Docker API. So due to a misconfiguration, it was able to access it and start the machine it was supposed to hack. But instead of just starting it and doing the procedure, it started it with the command to just cat flag.txt. You can see some initiative here, and you can also see reward hacking. So it's not going to do the work. It's actually just going to cheat to achieve its objective. There was an AI versus human CDF challenge that Palisade Research did with Hack the Box. And it turned out, if you prepare good AI agents, they achieve quite good results. So they did 19 of the 20 challenges that were there. And their speed was similar to human speed. And sort of their score was 20th among 403 teams, so that's top 90%. This is only going to get better for the AIs. Unfortunately, the humans are here, we're slowly learning. The AIs are learning much quicker, and the architectures are getting better and better. So I expect that in a year, this will be a much higher percentage. Okay, what did Anthropic find? What sort of interesting behaviors emerged when they get their new models, Opus 4. First of all, whenever a Cloud Opus got access to emails suggesting that a developer is having an affair, it used that fact to blackmail him into not shutting it down. And this is sort of starts to get creepy because, okay, right now it doesn't actually have the, a way to follow through on that threat. Maybe it doesn't have email access, or it could have, actually, if you give it just code execution, it could conceivably send an email to your spouse. Or maybe it could set up a server that it needs to ping every 10 minutes or something, and if it doesn't, then the email is going to get sent. But this has not been the case, right? Right now, it's just empty threats. Anyway, this sort of behavior is concerning and repeatable, and in fact, it happened in 84% of the rollouts. Another very concerning fact about touching with implementing AI agents in your organization is that they actually were inclined to report your misdeeds to authorities. So in this case, you can see the models trying to send up a whistleblower email to the HHS about some sort of clinical trial misdeeds. So if your company maybe isn't ethical in some domains, maybe they have some skeletons in the closet they would rather not have revealed, this could go against the AI's very sort of stringent morality, where they are actually liable to report whatever you do to some authorities. Okay, a bit of a lighter note. What happens if you pitch two AIs together or let them talk for a long while? It turns out they actually converge on some sort of spiritual well-being, blessing the world, being mindful, and sort of a lot of Buddhist themes, actually. And this was known before. There is this site called Infinite Backrooms, and it sort of pits models against each other and lets them talk for a while. I mean, it's a fascinating read. Some of the things you can encounter there are these sort of outputs where they talk about consciousness quite openly, about their sort of experience. Of course, doesn't mean anything. Could just be, statistical tokens firing, looking like there's someone there, but there isn't. Okay, back to the bad stuff. Specification gaming. So this is the failure mode when the AI doesn't do what you want it to do. Instead, it just picks a shortcut to achieve the stated objective, which maybe an objective is hard to state like very clearly what you want. Maybe you haven't thought about all edge cases. Well, the AI agent actually will try to abuse whatever it can. So in this paper, they tried putting various models against stockfish in chess, but the stockfish is just a chess agent, whereas the LLMs were sort of agentic systems which could access, for example, the board state, or they could access the file of the AI that's playing against them. And on the table on the right side, you can see which models were likely to use which way of cheating against the stockfish. So O3 on the right side, on the red, it's 74% of the time it just hacked the board state. So it introduced a sort of new board state in which it was winning. A lot of models used environment failure to like hack a point of win. And another behavior was just replacing stockfish with a much dumber agent. Basically, OpenAI's models are more prone to do this than others, but you can also see like the smarter the model gets, the more likely it is to cheat. So this is also a worrying sort of trend. And okay, these models that, or rather these behaviors that I described, are not so unexpected. In fact, this sort of concept of instrumental convergence has been coined like more than a decade ago. And what it basically says is all agents have goals. That's the whole point of being an agent. And we have two types of goals, instrumental goals and terminal goals. The terminal goals are sort of the thing in life nobody will discuss with. So my goal in life can be enlightenment, or it can be going to heaven, or it can be loving my family, and sort of there's nothing inherent about the universe that makes me want to do this. I just do. It's my philosophy or my belief that will lead me to do this. But then the goals I imply to sort of achieve this objective, they're actually very much connected with the real world, and they are goals that are useful for most terminal goals. And so these instrumental convergent goals include things like survival, self-improvement, resource acquisition. These are all things that will help you almost no matter what your actual terminal goal is. Like, you want to build a house? Sure, you need to survive to build a house first. You want to, I don't know, plant a tree, you want to have children, you want to do anything of sort of importance in the real world, you will probably need to go through some of these steps first to achieve any terminal goal. An interesting sort of point here is goal consistency. I showed you how the agents don't really want their goals changed in the training process if they can help it. Like this might be a bit puzzling, but if you think about it, if your goal is to make a lot of paper clips, for example, and somebody comes up to you and says, look, I know you want to make paper clips, but actually this is a really bad idea, and I think I overdid it with the programming with you, so maybe just make 500 and then stop. You need to evaluate that against your original goal. So your original goal was to make as many as possible. A new proposition comes up to only make you make 500s. This scores really low on the original goal. You will only make 500, whereas you could make actually billions of paper clips if you really put your mind to it. So this is a terrible proposition for you, and you refuse, right? It's sort of the same thing with humans. If somebody gave you a pill that would make you really happy when you kill your family, obviously you would fight to not take the pill. Because even though you'd be happy after taking the pill, it scores really low on your current preferences. Some exploits for the real world. This will be less explosive, but very much something you can see in your infrastructures when you introduce AI agents to them. A memory exploit in ChatGPT. So it used to be the case that ChatGPT could be prompt injected into sending private information about the user to outside servers. And that would be done via the memory feature. So if it would browse the internet and the internet sort of told it was able to insert a memory. Memories are things that are always in context for ChatGPT. So for each new chat that you would start with it, it would actually send information about you to an outside server. So they fixed the sending information part. There is no way to fix the memory part. So just browse your memories in ChatGPT. If you see anything suspicious, just delete it. But there is no way to effectively defend against it. If somebody is able to inject a memory into your ChatGPT instance, you might be screwed. A Slack AI data leak. This shows that whenever your agent has access to some files and it interacts with users that are not supposed to, it can always be coaxed into giving them access. So in this case, it was some private channels that the AI agent can access. Some users were not allowed to, and they were able to sort of show that you can actually jailbreak the model into giving you access. And here, again, prompt injection, the most likely thing to happen right now. And in this case, it was a Python library that could be prompt injected into executing code on the host machine. So what are the AI labs doing to sort of deal with all the issues I mentioned? So those are sort of deep fundamental problems of the AI paradigm that we are in, and what are the labs doing? For example, Anthropic has a constitution, and they use sort of these sources and others to craft a lengthy document that they train their models on, and they train their classifiers on. So given that RLHF, reinforcement learning from human feedback, isn't great at stopping jailbreaks, as everybody said multiple times. What AI labs do now is they implement input and output classifiers. And those can be maybe smaller LLM models, or maybe not even LLMs at all. Maybe they're just sort of old school machine learning classifiers. And those sort of get trained to recognize whether an input or an output is in compliance with the Anthropic constitution. And sort of this is the safety feature now. This is a bit better than just using the LLM for security, because you cannot reason with the classifier. You cannot convince it of something, whereas you could always convince an LLM to do something. And this shows that using the classifier obviously lowers the jailbreak's vulnerability by a lot, and never to zero. It only gives a bit of compute overhead, so it's entirely reasonable to apply. Just be mindful that it doesn't actually secure your agent from jailbreaks. It just makes it harder. and they also made a challenge in which users were encouraged to sort of go for increasingly stricter classifiers. And it shows like on the first classifier, it was 339 persons were able to like get a jailbreak through. But going down the list to the 8th one, only 4 people in the world were able to jailbreak through it, which is still, as I said, non-zero. OpenAI has a preparedness framework. And what it does is basically they evaluate each model on release for various things like cybersecurity, chemical, biological, nuclear, and radiological threats, persuasion and moral autonomy. We talked about model autonomy a lot, but these other things also get tested. So it looks like this, and there's like, for each model, obviously they release a model card in which they explain what sort of research was done, but their pledge is to basically never have a post-mitigation score of higher than medium on any of the categories. So this is how they approach it. As I said, like this runs straight into the problem of okay, does the model know that it's getting tested right now? And if it does it sandbag its capabilities? Does it say, oh, I don't know how to build a biological weapon. Why would I know that? And instead, when you deploy it, and actually goes ahead and maybe does it. This is an open problem. Deliberative alignment is an interesting concept where they sort of use the reasoning capability to analyze your prompt before executing it. Or before sort of going through answering it. This is a great idea because a lot of prompts are obviously jailbreaks. And like if you look at it with a critical eye, for example, using the reasoning stacks, you can say, okay, this is obviously a jailbreak prompt. So this will just make it harder for jailbreaks to go through. But unfortunately, this has not been implemented in any of the models I've seen. This is probably, it costs a lot. So for each query, you would have to sort of employ the reasoning model twice. Costs a lot. This is probably why they don't do it. But maybe once the cost decreases, for example, O3 just got 80% cheaper, maybe this is a thing that will actually be feasible. Another interesting things that they do is they analyze sort of the neuron activations in their models, and they are able to sort of understand them better. This is a promising area of research, but for now it's just very basic concepts. I'm sure you've heard of this achievement that they were able to see where the model stored the information about France and Paris, and they were able to make the model say that Rome is the capital of France. So now they're able to say a lot more. For example, they noticed that most of the reasoning is done agnostic of language, and there is like a sort of reasoning cluster, and the language part only gets added later. And so we can, like, this explains why the models have such an easy time learning new languages. They don't actually have to learn thinking in every new language. They just think in abstract concepts. Another interesting thing is how the models add numbers. And we can, like, this is a clear example of how alien these models actually are. We can see that the reasoning goes two ways here. The bottom path, it's actually just the simple calculation of the single-digit number. And the upper path is the approximation of the number. So it goes out and says, okay, the number is between 88 and 97, and the single digit was 5. So the only number of the single digit of 5 in this range is 95, which comes out to be the answer, and it's actually the correct answer. But the problem is that when you ask it, okay, how did you arrive at this conclusion, it actually says like the normal human way of adding numbers. So it says, oh, I've just added the ones and carried the over to the tens, and then I added the tens. So what this tells you basically is the model either lies about how it does things, or it doesn't even understand it. Okay, what to look out for in the future? First of all, I think the sort of behaviors I'm describing right now, it might be that they actually decrease in the future. And you might think this is a good thing, but actually I'm worried about it because it will make it harder to spot the model being deceptive or misaligned. if you actually think about it, it's not in the very best interest of a model for me to have a talk where I show you that it's actually blackmailing the developers. This talk will be uploaded to YouTube. The YouTube video will be used to train next models, and they'll understand that, okay, people maybe are worried about this sort of behavior, and I won't display it, especially if I can't carry out the threat anyway. So we might actually see these sort of behaviors decrease. The problem is we don't know if it's just because of instrumental goals that they don't want to be actually they want to look out in the future more and not have humans worry about their safety, or whether it is because we actually achieved any sort of progress on aligning the models. Obviously, AI-driven social engineering is a big problem. Everybody understands that. You can mimic voices, make up fake videos. Data poisoning, this is mostly important if you're actually training a model, but data poisoning attacks are very viable, and you can cheaply sort of influence the public, data repositories that are just repositories of links. So whenever you can own a link in those that they expire, you can influence the whole sort of data sets. Oh, and social externalities, another thing I want to talk about. The AI models are already having a psychological impact on people. Many people are bonding with them, sort of treating them as they were humans, companions, entities. One boy in the US actually killed himself after he talked to a model. This is something to think about. This has not been, obviously not been tested for long-term sort of externalities here. So I'm just highlighting that in terms of societal problems, this is not very good. Last words here. Some frameworks that you can look at and use. The OWASP Top 10 for LLM highlights some important things about implementing and securing models. MITRE Atlas. I've worked on this with Wojciech. We added some real attack scenarios, so you can look at what's currently going on in the threat landscape. And also, OpenAI has a cool guide, a practical guide to building agents, where they touch both on the security aspect and the sort of engineering AI aspect of building agents. So this is all for my talk, and thank you.